Hello friends, welcome to the Boolean Brain in continuation to the LeetCode Daily Challenge series where we are solving the daily challenge from LeetCode. So we are on day 14. Let us try to solve today's problem statement. The title says separate squares 2. So we are given a 2D integer array squares. Each squares of I is xi denoted by xi, yi and li represents the coordinates of the bottom left point and side length of a square parallel to x-axis. So we have given coordinate of this point and the coordinates of x, y, the bottom left corner and the side of a square. So in the minimum y coordinate value of horizontal line such that the total area covered by squares above the line equals to the total area covered below the line. Okay, so we have to find a line minimum line parallel to x-axis such that the line separates the squares above and below with equal area. Answers within range 10 to the power minus 5 of the actual answer will be accepted. Okay. Note squares may overlap. Overlapping areas should be counted only once in this version. Okay. So if you are solving and following the series, yesterday's problem statement, the day 13 problem statement was similar one. It said separate squares one, wherein the problem statement was exact same. Apart from that, this only line. Overlapping areas should be counted multiple times. But the today's problem statement mentions that overlapping areas should be counted only once. So this one line completely changes the way how we should approach to this problem statement. In the yesterday's problem statement, we simply went ahead with approach of binary search. We had a maximum y range and the minimum y, and we just tried to find the minimum y such that it satisfies the condition of having squares of areas, squares above and below of equal areas. But today, since it mentions that i- overlapping areas should counted only once, this becomes a very interesting and challenging problem. As you can see, the tide difficulty level is also hard. So the normal binary search approach won't work because it mentions of calculating the overlapping areas. So how can you approach of such problem statements? Whenever a such problem statement appears, how should we think, right? Let us try to discuss that. So the problem statement mentions we have to find the minimum y. That is for sure. We have to find the minimum value y such that it divides the area. Now, if you carefully see, if the input is something of this sort, it is fine. Okay. This is the ideal good case. But if the input is of this this example, you can carefully see if you divide a line at this point, so there are two squares. One is starting at 0, 0 of size length 2, and there is another one, 1 comma starting another square starting from 1 comma 1 of side 1. If you carefully observe, the second one is completely submerged into this, isn't it? So if we just split the square into half, this line, the area of the below is the height 1 and the width is 2. So half area of below this line is 2. Similarly for this, the maximum width here is 2 and the height that is 1. So we should only take care of this, right? We already computed below this. The height is 1, the area width is 2. So we calculate the 2 into 1 is 2. So if you carefully observe, I mentioned about calculating the overlapping range of x, right? We want, and this y-axis denotes the height. So if we somehow starts working on the area level by level at each points and try to find out the area submerged below it. For example, when we are here, we just want to find what is the overlapping range. What is the overlapping range such that all such squares coming below this area can be computed, isn't it? Okay, looks good. So now we are sure that we want to find range, find the overlapping range, isn't it? Now let us try to look at constraints if they are providing us any hint. The length of squares mentions 5 to 10 power 4. Similarly, the coordinates can go up to 10 power 9. Okay, and the total, mm, yeah, so total squares of length can go up to 10 power 4, right? It means 10 power 4 such squares can be possible. If we go ahead with some brute force approach to figure out the overlapping range, it might go into time limit exceeded because it would run out of time. So in order to do that, we want overlapping range, and if you carefully observe, we want this in incremental way. We want the incremental, we start iterating from bottom to up. At each position, we want overlapping x intervals at this point only. Similarly, at this point, we want this. So this clearly helps us. We want multiple updates because these new elements are being added, new range squares are being added, right? So multiple updates, and we at each point we want to query to find the range, isn't it? So again, saying you this problem is not easy and not that much intuitive. You must be aware of some concept of a data structure known as segment tree. So segment tree is a data structure. This itself is a different topic. We will not go into details of how it is implemented or how it works. If you want how segment tree works, I will create a separate video. Please do let me know in the comments. For this video, I'll briefly explain when to use segment tree or when to identify segment tree is required. So whenever we want query is given and we want to work on the range. So range and query. So these are the keywords and point updates. So these are some of the keywords. When you hear this or figure out from a problem statement, you have to think of segment tree. How we will apply, I will show you in this video. Now, so this is clear approach and logic is clear. Now let us try to work on how do we wo- implement this solution. Now, as I mentioned you, each point, uh, each point in squares is a square. This is the starting point. This is the side. So if you can see, I create a vector of events. The event is nothing but, let me minimize this. Yeah. So event is nothing but it is helpful for me to track two events, the starting point and the ending point. So whenever I am I come across a square, I want to track the y coordinate so that this point I can track. Now I also want the type. The type is nothing but if the interval of the square is being added or it is being subtracted. Where it is used, I will explain you in the later stage. For now, just I think of this as identifier to demarcate the starting or the ending point. Okay. Similarly, we have the x1 and x2 coordinates. So these x1 and x2 are nothing but if I am at this point, x1 is the coordinate of this and x2 is this. Similarly, when I'm at this position, the x1 and x2 are this and this. Now, if we carefully observe, yeah. here. So we declared the events. Where it is be used, I'll show you now. But I also need a track of all the x coordinates based from the given input. You might ask, why is it used? Of course, it is used because for a given y, I want to find the range of overlapping range, right? That's when I want to use this access to keep a track of x coordinates. So these x coordinates are will be used in the segment tree to help give me the updated or the overlapping range. Okay. Now I create sweep events and collect the x coordinates. I start iterating on squares. I figure out x, y, and the length. As I mentioned, I push back the y. The +1 indicates for starting, and x indicates the range of x coordinate start and x coordinate end. Similarly, we remove this interval at the edge. So what should be the removal point? Y plus length. Y length because length is the side of square. So starting from this position to this position. Okay, I simply push two events and I also push the x coordinates. Now my S contains all the coordinates. Now it is high possibility that it contains some duplicate, and we want to avoid duplicates because duplicates would create double areas. So first, in order to remove the duplicates, I first sort it in ascending order. Then I remove the duplicates out of it. So this basically creates, like, it's nothing but a coordinate compression on the x-axis. So if my elements contain 1, 2, 2, 3, now it would at the end it would contain 1, 2, and 3. Now x coordinates are sorted till here. That is fine, cool. Now I also want to sort the events. Why I want to sort the events? Firstly, what events contain? Events contains the y coordinates. It basically represents a square. So I also want that to be in a sorted order. I sort it out. That's what it is doing. Now I want to create a map of x value to compressed index, the index which we updated here, right? In order to keep a track of element to index, I create this index map. It will be used in the later stage. I will show you. Now, this step 2 is complete. Now, in the next step is nothing but the sweep. What is a sweep? We move from y point, we move the y on the y-axis, and right in the first sweep, we fetch the total area. And in the second sweep, we try to reach a point which satisfies the condition of the splitting into two equal halves. Okay, now we are working on the first sweep. Now I declare a segment tree. If you are not aware of segment tree, just assume it as a data structure for now. And if I'm passing this array and I want to do these two operations, I want to query it and I want to update it. So in our case, two operations are query and update. Okay, so yeah. So I declared a segment tree first. I'll show the implementation of segment tree as well, but for now, just think of this as black box. So we are declaring a segment tree st. Now I want to start from this point, right? So this is nothing but the start point of the first index. So events of 0 of y. Now this contains the first point on y-axis. Total area is assigned to 0. I start iterating on all the events and I find the difference between the current coordinate and the previous y coordinate. Previous was 0, so current is in this case, if you are talking about this case, current is also 0. So this dy will come to 0 and the total area would be updated as 0. Now you might ask, why are we calculating this difference? We are calculating the difference between the current and the previous because Once we are aware of this height, we are working in heights, right? If we are no, sure about this height, and we somehow know the width, which is going to come from the segment tree, we can calculate the area of this part, isn't it? So that's the reason I'm calculating the difference. Total area is updated here. And now the critical stage of updating the intervals. So the up till now, this area is computed now for the current square. So each element in events is nothing but an event of a square, the starting or ending, right? So I want to update the x internals based on it. So I simply pass the x1 and x2. Again, the segment tree works on the indexes, not on the actual values. So we created this map, map, x index, right? Yeah, here. So we created this x index map where we were storing the indices. So that's the value I need to pass in the segment tree, and that will work on indexes. And I also pass the type. You might ask what was the use case of type? So type is like when a plus one type is passed, we want to consider it into the index. Okay, in while calculating the range. And if we pass minus one, it means this 0 to 1 width is no longer applicable from this point. So we have to remove it. So how does that operation happen? It happens based on this type. You can see the implementation of update, then we will understand this. Okay. Again, I updated the previous y with the current y. At the end, this entire loop will give me the total area of the all the squares, overlapping squares. Now, to calculate the half, I simply divide it by 2. Cool. Now, next stage is of calculating the, in the second sweep, we have to find the y where area reaches half. Since now we know the half, we have to find y where the area is reaching. Again, I declare another segment tree. I pass the similar x coordinates to this, and my previous y is the same, the starting point of the initial starting event. And I declare another variable accumulated. Accumulated is the current sum, basically, current sum of areas. Start iterating on the events. I calculate the height. This dy is giving me height. This current width is obtained through query. st2.query. I think I forgot mentioning about the query in this first sweep as well. This st.query. So this is nothing but the magical function from the implementation of segment tree, which gives me the maximum range. This is the maximum range of common elements in the x-axis. So the width is given to me by this st.query. Okay, cool. Yeah, we were here. So current width is determined through st.query. You will hear more about this query function when we look at the segment tree details. And now, in order to calculate the area, I simply multiplied the width and the height. I obtained the area. Now, I need to check if my accumulated area plus my current area, if that is greater than equals to half, that means whenever this condition would be triggered for the first time, that means we have reached beyond to a point where we want to basically up return the answer, right? So uh, if my accumulated plus area is greater than equals to half, then the answer is the previous half plus half minus accumulated. So whatever the extra difference was, because I'm adding condition of greater than equal to, so this might exceed the half, right? So I want to check what is the exceeded difference by half minus accumulated divided by current width, because I need to do this because this accumulated and this half minus accumulated gives me some area, right? If I divide the area by the width provided by the segment tree, I will be able to find the height. I simply need to append that height into this. It means if this half minus this, whatever the difference it will give, and if I divide this with current width, it will give me the remaining portion which was remaining, and I need to append this into previous one. Now, if this is not true, this would be executed only once, and that is the returning case. Else, otherwise, I will append the current area into the accumulated and update the index, because this is very critical stage. Once you calculate the area, you update the index. While updating index, we simply pass indexes of the x1 and x2 coordinates and the type if the square is starting or ending. And again, I update the previous, and since previous is the value which is being tracked, that is our answer, and we simply return the answer. Okay, now let us try to quickly take a look at segment tree. Again, guys, I'm not going more detail into segment tree, because if I only explain segment tree, it will be uh, half an hour video. Okay, so segment tree in the initialization, I'm assigning the size, whatever the input of array that I receive here, I receive 4 times of that into count and length. So count is internally used in the pushup function, and the length is the one which was storing the range, maximum range, which we require, right? So you- we were calling these two functions. If you carefully observe, we were calling this update and query. So query was returning me the length, but the length was populated by, yeah, the length was populated by the pusher function, and pusher function was updated through the in the update function. So when each time we were calling the update function to add the coordinates of x1 and x2, that time it internally was keeping a track and maintaining the range, the maximum value common into the length data structure here. Okay, and these are all recursive functions. This update is a recursive function. We figure out the mid, we go pass on to the left, we pass on to the right, and we call the pusher function. And similarly for calculating the query, since query would our expectation from query is basically it should give me the total union of length on the x-axis, right? So it simply returns, which is stored at the top, it simply returns the that element. And this function was helping us identify the width. Height was determined from y, but width was determined from the query function. Okay, and yeah, so I explained about this. This is the functor required for sorting the custom data structure, that is the struct of event type, and that's how we should be able to solve this and work. I know this might go a little overwhelming, but once, in order to understand this completely, the sequence is you have to work on segment trees, and then you would also need to work on geometry concepts involving involving overlapping. Okay, these are some areas of learning areas which one should focus in order to come up with solution. I hope. Okay, I think forgot about time and space complexity. We just quickly discuss the time and space complexity. If you carefully observe, if you carefully observe, um, we are doing sort. Sorting is nothing but n log n. Apart from that, we are again one more time sorting. So sorting is n log n. Apart from that, we are calling the point updates, the query and update. So as you saw, implementation of query is nothing but a simple O of one logic. So this is okay, but the update function is internally going to be update function is going to internally go into left and right and update it at the right position. So it would go, since it's a binary tree, it would go into the login. So this update is login and this is n. So maximum time complexity is O of n login. Apart from that, in terms of space, we are not using any extra space apart from storing the uh, storing the indexes. So for the segment, for building the segment tree, so that is O of. As you can see, we have declared size of 4n. Again, if you want, how did this 4n come here? It is because when a uh, size of n, array of size n is going to be stored across segment tree, we split it into two nodes, right? At each range, in order to figure out all the ranges into a binary tree, you would need minimum 4n nodes to store all the elements. So it's 4n, but still it's order of n only. Okay. Yeah, I think with this, let's try to run this once. Okay, let's submit this. Okay, great. Yeah, so that's how I feel. I hope the problem statement uh, uh, on the yesterday's and as well as today's, and the way we had to uh, come to this approach and choose this and not the binary search is clear to you. Segmentary can be a little bit new, but I think that can be discussed separately, and that is very easy. You just need to master these three functions, and rest is very simple. Okay. If you have any doubts and queries, please do let me know in the comments. If you're new to the channel, please consider subscribing it and please give a like to the video. Thank you.